Imagine a world drifting alone through the cosmic void. No sunrise will ever grace its horizons. No sunset will paint its skies. This is a planet untethered from any star, wandering the galaxy in eternal darkness. A rogue planet, and there could be billions of them, lurking unseen in the spaces between the stars. Right now, as you watch this video, countless planetary nomads are silently gliding through our galaxy. Some might be passing through our solar system's outer reaches, invisible and undetected. These cosmic orphans challenge everything we thought we knew about planets and force us to confront a haunting question. In a universe where we define planets by their relationship to stars, what do we call a world that belongs to none? Welcome to today's journey into one of astronomy's most enigmatic phenomena. I'm your guide into the realm of rogue planets, worlds that have either been violently ejected from their home systems or formed alone in the darkness, never knowing the warmth of a parent star. Our story begins not in the depths of space, but in a university office in 1998. Dr. David Stevenson at Caltech was pondering a radical question. Could planets exist without stars? The scientific community was skeptical. After all, our entire understanding of planetary formation was built around stars as the central architects. But the universe, as it often does, had surprises in store. In the year 2000, a team of Spanish astronomers working at the Roque de los Muchachos Observatory made a startling discovery. They found objects in the Sigma Orionis cluster that were too small to be stars, but showed all the characteristics of planets, except they orbited nothing. These objects, roughly the mass of Jupiter, were floating free in space, challenging our very definition of what a planet could be. The astronomical community was divided. Some argued these couldn't be planets at all, proposing instead they were failed stars, brown dwarfs that never quite made it. Others suggested a more unsettling possibility. These were true planets that had been cast out from their birthplace, doomed to wander the galaxy alone. To understand rogue planets, we must first understand how they come to be. There are two primary paths to planetary orphanhood, and both tell us profound stories about the violent nature of cosmic evolution. The ejection hypothesis. Picture a young solar system, chaotic and crowded with forming planets. Gravitational interactions between these young worlds can be catastrophic. When planets pass too close to one another, one can be accelerated to escape velocity and flung into interstellar space. Computer simulations suggest this might be surprisingly common. For every star in our galaxy, there could be thousands of ejected planets wandering the darkness. Dr. Dimitri Veras from the University of Warwick explains it like a cosmic game of billiards. When you have multiple massive planets forming in the same system, it's almost inevitable that some will be scattered. The unlucky ones achieve escape velocity and become rogues. The isolation hypothesis, but not all rogues are exiles. Some may have formed alone, condensing directly from collapsing clouds of gas and dust without a star at their center. These planets would have never known sunlight, born in darkness and destined to remain there. The smallest of these could be Earth-sized or smaller, invisible ghosts haunting the space between stars. How do you find a dark planet against the black backdrop of space? It's like trying to spot a black cat in a coal mine at midnight. Yet astronomers have developed ingenious methods to detect these elusive worlds. The primary technique is gravitational microlensing. When a rogue planet passes between us and a distant star, its gravity bends the star's light, causing a brief brightening. It's a one-time event that will never repeat for that particular rogue and star combination. A cosmic flash in the pan that astronomers must catch in the moment or lose forever. In 2020, astronomers using the OGL, Optical Gravitational Lensing Experiment, telescope network, announced the discovery of the smallest rogue planet candidate ever found, possibly Earth-sized. The detection lasted only 42 minutes, the briefest microlensing event ever recorded, suggesting the object was incredibly small by cosmic standards. Dr. Przemek Mróz, who led the discovery team, described the challenge. If we observed only one source star, we would have to wait almost 1 million years to see the source being microlensed by a rogue planet. What would it be like to stand on a rogue planet? The answer depends dramatically on the type of rogue world we're visiting. Gas giant rogues. Large rogue planets, similar to Jupiter, might not be the frozen wastelands you'd expect. These worlds could retain heat from their formation for billions of years. Their thick atmospheres would trap this warmth, and radioactive decay in their cores would provide additional energy. Some scientists speculate that the upper atmospheres of such worlds might even be warm enough for certain types of chemistry we associate with life. Rocky rogues. Smaller, Earth-sized rogues present a different picture. Without stellar radiation, their surfaces would be frozen solid, with temperatures approaching absolute zero. But beneath the ice, things get interesting. Radioactive decay could maintain liquid water oceans under kilometers of ice. If such a world had formed with an atmosphere, it might retain it, creating an insulating blanket over an ice-locked surface. Dr. Dorian Abbott from the University of Chicago has proposed that Earth-sized rogues with thick hydrogen atmospheres could maintain surface temperatures above the freezing point of water. Through the greenhouse effect alone, no star required. These Steppenwolf planets, named after the lone wolf, could theoretically harbor life in eternal darkness. Could life exist on a world without a sun? This question pushes us to reconsider our assumptions about habitability. We tend to think of life as dependent on starlight, but Earth itself shows us alternatives. Deep in our oceans, around hydrothermal vents, entire ecosystems thrive in complete darkness. These communities derive their energy not from sunlight, but from chemical reactions. Chemosynthesis instead of photosynthesis. Bacteria convert hydrogen sulfide into organic compounds, forming the base of a food web that includes giant tube worms, blind shrimp, and other extraordinary creatures. If life can flourish in Earth's lightless depths, why not on a rogue planet? A subsurface ocean, heated by radioactive decay and tidal forces from any captured moons, could potentially support similar ecosystems. The energy wouldn't be abundant, and evolution would proceed slowly. But given billions of years, who knows what might emerge? Dr. Lewis Irwin, who has studied exotic habitability, suggests the subsurface oceans of rogue planets could be among the most common habitable real estate in the universe. We might be the outliers, living on the surface of a sun-warmed world. The scientific community remains divided on fundamental questions about rogue planets. These debates reveal how much we still don't understand about planetary science. How many are out there? Estimates vary wildly. Conservative calculations suggest there might be as many rogues as stars in our galaxy, around 200–400 billion. But some models predict far more. Dr. Louis Strigari's team at Stanford calculated there could be up to 100,000 rogue planets for every star in the Milky Way. If true, rogue planets would outnumber stars by a factor of 100,000 to 1, making them the most common planetary bodies in the universe. The definition, dilemma. What exactly constitutes a planet when there's no star involved? The International Astronomical Union's definition requires a planet to orbit a star, technically excluding rogues. Some astronomers propose calling them planetary mass objects or isolated planetary mass objects. Others argue for expanding our definition of planet to include these wanderers. Dr. Alan Boss from Carnegie Institution argues, if it looks like a planet and acts like a planet, it's a planet, regardless of whether it has a star or not. The existence of rogue planets forces us to reconsider our place in the cosmos. If rogues outnumber starbound planets, then most of the universe's worlds exist in darkness. Our sun-drenched Earth might be the exception, not the rule. These wanderers also pose intriguing possibilities for the spread of life through the galaxy. Some scientists propose lithopanspermia, the idea that life could hitchhike between star systems on ejected planets. A planet expelled from its system might carry microbial life in its subsurface, preserving it during the long journey through interstellar space. If captured by another star system, eons later, it could potentially seed life in a new stellar neighborhood. There's even speculation about rogue planets passing through our own solar system. The mysterious Planet 9, hypothesized to exist in our outer solar system, might actually be a captured rogue. Some researchers suggest that Earth itself might have captured small rogue planets as moons in the distant past. The next decade promises revolutionary advances in our understanding of rogue planets. The Nancy Grace Roman Space Telescope, scheduled for launch in the mid-2020s, will conduct a census of rogue planets using gravitational microlensing on an unprecedented scale. Scientists expect it to discover hundreds, perhaps thousands, of these dark wanderers. The European Space Agency's Euclid mission and the ground-based Vera C. Rubin Observatory will add to this cosmic census. Together, these instruments will help us answer fundamental questions. How common are Earth-sized rogues? Do they have moons? Could any be passing near our solar system? Dr. Scott Gaudy from Ohio State University, who leads rogue planet research for the Roman Telescope, expresses the excitement in the field. We're about to open an entirely new window on planets that we never knew existed. Every discovery will teach us something fundamental about how planets form and evolve. Rogue. Planets challenge more than our scientific understanding. They challenge our philosophical perspectives on existence itself. These worlds embody cosmic loneliness on a scale that's difficult to comprehend. Yet they also represent ultimate freedom, unbound by the gravitational chains that tie other worlds to their stars. If intelligent life ever evolved on a rogue planet, what would their philosophy and science look like? Without a sun, they would have no concept of days or years. Without neighboring planets or a visible star, they might not discover that other worlds exist until developing incredibly advanced technology. The stars would be their only light, distant and unchanging. Would they even conceive of the possibility that some planets orbit those distant lights? Their poetry would know no sunrise metaphors. Their religions would speak of eternal night as the natural state of existence. They might consider starlit worlds like Earth to be impossible fantasies, too bright, too hot, too chaotic to support life. As we end our journey into the realm of rogue planets, we're left with more questions than answers. These dark wanderers remind us that the universe is far stranger and more diverse than our sun-centered perspective suggests. They float through the cosmos, carrying secrets about planetary formation, the potential for life, and the very nature of what we call a world. Somewhere out there, perhaps closer than we think, a rogue planet is passing silently through the darkness. It might be a frozen Earth, its oceans locked under miles of ice. It might be a warm Jupiter, its storms raging unseen in eternal night. Or it might be something we haven't even imagined yet, a type of world that challenges our every assumption about planets and life. The next time you look up at the night sky, remember that between those visible stars drift invisible worlds, cosmic wanderers following their own lonely paths through the galaxy. They remind us that in this vast universe, the familiar is the exception and the strange is the rule. What do you think lurks in the darkness between the stars? Could rogue planets harbor life in ways we haven't imagined? Share your thoughts and theories in the comments below. And if you enjoyed this cosmic journey, consider subscribing for more explorations into the mysteries of our universe. Until next time, keep looking up, but remember, not everything worth discovering shines with its own light. Some of the universe's greatest mysteries hide in the darkness, waiting to be found.